Assalamualaikum and hi to our dearest lecturer, which is Dr. Dila Eliana, Miss Shahira and Puan Rosanita. I am Rajana Dalila Batrisha binti Raja Zainal and my metric number is AA220665. I'm going to present the abstract and introduction of our research methodology project, which is the production of biodegradable plastic packaging film from cassava starch. So, most food packaging today use a material that consists of a variety of petroleum-derived plastic polymers, metals, glass, paper, and board, and a combination of those. Plastic is found to be the most reliable and the best because of its long life process out of those materials. Thus, its usage is increasing day by day and year to year. However, this plastic cannot be degraded by natural processes within a short period, which causes environmental problems as its waste increases each year. Burning and burying are the methods that are usually used to destroy waste. However, this method causes to another pollution that could give a hazardous risk to both our ecosystem and human health, and it is not suitable as it doesn't efficiently destroy the plastic waste completely. As the solution to this problem, it is found that there has been considerable interest in the development and production of biodegradable plastic. In this research, cassava starch is used in the materials to produce biodegradable plastic. So next is introduction. The increasing use of plastic in various industrial applications such as packaging, automobile and furniture production has led to its superior long-life properties. Plastic resistant to chemical reactions, particularly enzymatic reactions, make it necessity in many conventional plastic. However, natural processes cannot degrade plastic, causing environmental pollution problems. Burning and burying methods are not suitable for plastic destruction as they release toxic gases into the atmosphere and causes to health problems. Soil pollution is also caused by non-biodegradable plastic, while pyrolysis produces toxic fumes when degraded at high temperatures. The accumulation of plastic in the environment has numerous negative impacts affecting human health, the ecosystem, and the world. Scientists are now focusing on efficient ways to develop plastic that can be used effectively, driven by environmental concerns. Two simple ways to produce degraded plastic are recycling and reuse. Biodegradable plastic can be divided into few types, which are also degradable plastic, hydrodegradable plastic, photodegradable plastic, and biodegradable plastic. This type of plastic do not require any additional input as they can degrade naturally. Scientists and researchers are increasingly interested in biodegradable films made from renewable and natural polymers such as starch. Amylose and amylopectin are two types of polysaccharides that affect a film's strength and mechanical qualities. Plasticize, plasticize, Plasticizers such as polyols like sorbitol and glycerol are commonly used in starch films to promote flexibility. Biodegradable polymers decompose more quickly than conventional plastic, allowing for chemical or biological degradation into smaller molecules. This reduces landfill waste and energy consumption as biodegradation doesn't require external energy. Biodegradable polymers can be produced from microbial, animal and marine food processing industry or replenishable agricultural feedstocks. These materials generate ecologically benign products like carbon dioxide, water, high-quality compost, and renewable basic materials. Launching polymers made of monomeric repeating units are the building blocks of plastic which are essential in various industries like packaging, building, textiles, electronics, and transportation. They have replaced materials like glass, metals, and wood due to their adaptability, toughness, and affordability. However, plastic have drawbacks such as their inability to decompose biologically and their environmental impact. The decomposition of conventional plastic can take hundreds or thousands of years, causing environmental damage and species loss. Biodegradable plastics and materials derived from renewable resources are being explored as alternatives to reduce plastic negative impact on the environment. Currently, several materials have been used to produce biodegradable plastic with higher degradation efficiency, but limited methods exist to meet the degradable period of plastic, making plastic waste a major source of pollution. Cassava starch is a starch extracted from the cassava root and processed into a fine powder. Moisture content was tested using an infrared moisture meter. A biodegradable film was created using cassava starch, polyvinyl alcohol, talc powder, and urea. Tensile strength was tested using tensiometer tested biodegradable film specimen. The study tested three samples, tag A, B, and C, in a 500 ml conical flask mixed with potassium dichromate, sulfuric acid, distilled water, sodium fluoride, and diphenylamine indicator. Titration was performed using a ferrous sulfate solution in stock when the color changed from black to green and titer value was recorded. Synthetic polymers can be partially degradable by combining them with biopolymer and bioactive substance. Bioactive substances can break down plastic by combining them with swelling agents which stretch the molecular structure. Starch, a cheap, abundant natural substance, can be used to create completely biodegradable goods for specific market demands. By raising the air carbon dioxide captured by starch producing plants, the degradation or combustion of starch product closes the biological carbon cycle.
Hi, Assalamualaikum. My name is Siti Imelda Umairah binti Shiza. Today I'm going to present for our methodology, which is a production biodegradable plastic packaging film process from cassava starch. For materials and apparatus, cassava tubers and portable water are ingredients used to make starch. Cassava starch, talc powder, glycerin, urea, and water are among the supplies utilized in the making of films. A polyvinyl ester, such as polyvinyl acetate, is hydrolyzed to create water-soluble polymer known as polyvinyl alcohol (PVA). It is used to thicken, suspend, and emulsify liquids, as well as in adhesives, textile, and paper size. A basic polyol compound is glycerin. It is high boiling point and freeze to create a paste. It is an odorless, tasteless, viscous liquid. It is a plasticizer used in the making of films. A plasticizer is an ingredient that softens the substance, which is introduced. A mineral called talc, sometimes known as talcum powder, may be found in nature. It serves as the lubricant for this work. It serves to facilitate the mixture's smooth flow through the extruder. As a crossing-link agent, urea was utilized to make the starch and PVA compatible. Now I'm going to explain about cassava starch preparation, which is we are starting from the process of basic material by gathering ripe cassava. Remove the cassava outer skin and give the roots a good wash to get rid of any dirt or contaminants. Grate and extraction come next. Using a grater or food processor, finely shred the peeled cassava. The cassava is moved into a large tank or container. Make a slurry by adding water and making sure the cassava is well saturated. To degrade the cassava fibers and liberate the starch, aggressively stir the slurry. After that, give the starch slurry some time to settle, usually 6 hours to maximum to 12 hours. The lighter impurities will float to the top during this period, while the larger starch particles will sink at the bottom of the container. Pour out the water slowly, taking care not to disturb the starch sediment that has accumulated at the bottom. This procedure aids in separating the starch from other cassava ingredients. Next, for the drying and dewatering section, mechanical drying methods were used, such as laboratory oven set to 105 Celsius for 4 hours. Alternatively, Dry the starch sediment onto a flat surface or tray. The drying process can be achieved through various methods. One common approach is sun drying, where the starch sediment is spread thinly on clean surface, such as trees or large leaf, and exposed to sunlight. It's crucial to ensure that the starch is completely dry and the barest minimum moisture content as residual moisture can affect the quality of final film. Next, for the film preparation, the cassava starch is completely dry and will be for moisture content using an infrared moisture meter. This was done to ensure that the starch contains not more than 13% moisture. The powder starch is then mixed with pasteurizer and additive to enhance its flexibility, workability, and biodegradability. A mixture of 1 kg powdered cassava starch, 2 kg polyvinyl alcohol liquid, 100 g talc powder, and 100 g urea was prepared. The resulting mixture was added to 400 ml of glycerin. Commonly used pasteurizer include glycerol, which helps to improve the film's elasticity and toughness, and water, which aids in the plasticizing process. The whole mixture was stirred to yield a semi-dry powder. Thereafter, the mixture was then extruded with a blown film extruder to produce a biodegradable film, which can either be used directly or modified and processed further for use. Other biodegradable polymer or additive may be incorporated to enhance specific properties of the film, such as strength, moisture resistance, or barrier properties. The mixture is thoroughly blended to ensure the homogeneous distribution of components. The film was produced under the following condition: Zone 1, temperature of 190 Celsius, and Zone 2, temperature of 220 Celsius, melt temperature of 200 Celsius, film diameter of 300, and extruder speed of 60 rpm. Inside the extruder, the mixture is heated, melted, and forced through a die, resulting in the formation of a continuous thin film. The film is then cooled, solidified, and wound onto rolls. And for film's treatment and finishing, it is depending on the desired properties and characteristics of the film. Additional process may be employed to improve its mechanical properties and functionality. This process can include stretching or annealing, which help align the polymer chains and enhance the film strength and flexibility. The film may also undergo surface treatments or coating to improve printability, moisture resistance, or other specific requirements. Lastly, once the film is ready, it is cut into desired size and shape suitable for packaging application. The biodegradable plastic packaging film is then packaged, typically in rolls or sheets, and prepared for distribution and use in various industries.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Nulaila Shafia binti Azhar, and my matrix number is AA222185. So today I will explain to you about result and discussions based on our case study. So for this figure, it shows the tensile strength test result for the biodegradable film, which is the first figure. It shows force versus extensions, and the second figure it shows stress versus strain. So this is for further explanation. Okay, so from the result, it can be observed that biodegradable film has the highest tensile strength compared to paper and polyethylene plastic, and to improve its mechanical strength. It could be because of the glycerol used in the biodegradable film production, which was added. Okay, so moreover, it less permeable to water, vapor than ethylene based on films. Other than that, glycerol films are more rigid and less permeable to water than sorbitol films, which are less rigid and less permeable to water. Okay, more research is needed to better understand the connection between protein, lipid, and essence in firm matrix polymer in order to build more uniform films. Fiber reinforcement is an excellent replacement even when used as a secondary paper material to improve the mechanical and water sensitivity of the film. So just it. Okay, so for figure 2, it shows the biodegradable test result, which is we have three specimens. A stands for biodegradable film, B polyethylene specimen, and lastly C paper. Okay, so biodegradable test result for initial value. The green one is initial value for A, we got 4.3, final value 13.9, and titer value we got 9.6. For polyethylene specimen, initial value we got 13.9, final value we got 24.4, and titer value, which is final minus initial value, we got 10.5. And lastly, we got paper. For the initial value, we got 24.4. Final value, we got 32.7. And total value, we got 8.3. And blank, initial value, we got 3.5. Final value, we got 14.3. And total value, we got 10.8. So for the explanation, for figure 2 indicates the important test result of biodegradable plastic from the cassava starch that made from extracted from the cassava root and processed into a fine powder. Okay, so from the data above, it has been noted that the blank detail value is higher than others compared to paper, polyethylene, and biodegradable film. So this suggests that the desired organic stuff is present in the sample A, B, and C. So moreover, for specimen C's, paper can biodegrade faster than the other two specimens because it contains more organic material. On the other hand, the starch content of specimen A, which is the biodegradable film, may explain the reason it contains more organic material than specimen B, the polyethylene. Next, this phenomenon could be due to the content compound that accelerate their decay or breakdown in the presence of oxygen and light. Thus, biodegradable plastics are a better alternative as they are broken down easily and can be absorbed by the soil or converted into compost. So, just it.
Okay, so for the overall, our journal research for our topic, and for the conclusion, based on what has been found, it can be said that in terms of biodegradability, bioplastic made from cassava starch is preferable to plastic made of polyethylene, since it can break down into soil within 45 days and will not cause pollution. Polyethylene plastic had better tensile strength. The issues involved in handling plastic waste are multifaceted and intricate, and numerous studies have demonstrated they are getting worse over time. The resource required to confront this escalating environmental crisis and practical long-term solution will need to be produced by society future generations. Research and development of bioplastic by integrating innovative biodegradable packaging options made from renewable less materials. We may help address the environmental issue of the rapid global increase of plastic waste. As a result, bioplastic produced from organic cassava starch lack sufficient tensile strength to serve as packaging materials. Thank you.